Hey everyone, this is Mr. Hausman, and we're going to take a look today at Earth's magnetic field. We all know that our planet has a magnetic field, and we're going to find out where it's from, what causes it, and kind of how it benefits us. So let's start with the basic idea. This is page number 13. So if you are in period F or G, it's in your regular packet. Now, if you're in period A, it's in the supplement. It's still labeled as 13, but it's the supplement, page 13. We got it on Monday, and there will be extra copies for this lesson for people who weren't here. So how does this happen? How does our planet have a magnetic field? Well, the most abundant evidence we have is that in the core, there are moving iron atoms, and specifically they're ions, so they're charged. And there are so many of them in the outer core. The outer core is the liquid part, not the solid inner core, but the outer core, that it creates currents, that is electrical currents because they're charged after all, and the moving currents, they're called convection currents because they're heating up and they're rising toward the surface and then they sink closer back to the core. And what that does is it makes a giant magnetic field. Now, they come out of the north, and yes, that is correctly labeled. The southern hemisphere of our planet is a north pole, and it goes in toward the magnetic south pole. So that's why a compass needle lines up facing the North Pole, because the place we call the North Pole, because the compass needle's north end is actually attracted to the magnetic south pole of our planet. And hence we can orient our maps because we know where north is. So Earth's magnetic field is incredibly important. It saves us or preserves life on this planet 100% every day that it has ever existed. And to our knowledge, our planet, I don't know if we actually had a magnetic field when our planet was formed, but it has been around for billions of years. That magnetic field gets stronger, it gets weaker. It has even done something called flipping. We've had pole reversals several times. In fact, pole reversals happen about every 200,000 years. Misspoke there. Every 200,000 years, our poles reverse polarity. So there is really no written human record of that happening since Homo sapiens have existed, but throughout the history of our planet, we know by looking at geologic formations and analyzing it. So let's talk about this magnetic field saving us. Well, not too far away is a massive hot object, right? That's our sun. It's not the largest star, far from it. It's actually considered a medium to small star. And the way that stars work is that they are constantly doing nuclear fission. Oops, misspoke. Fusion, sorry. Fusion. Fusion means you take two hydrogen atoms and you smash them together with high enough energy to produce helium and a ton of energy. And that energy travels through space as light, UV, visible light, X-rays, all kinds of things, but it also generates something that we're going to call a coronal mass ejection. It's basically like a small-scale explosion on the surface of the sun. It doesn't destroy the sun, but it creates a storm of charged ions. So different than the ions in the center of our Earth, but these ions come through space and bombard the Earth constantly. And of course, an ion means it's charged. It's a charged group of atoms. And if we allowed that coronal mass explosions, ejections, to hit our planet, we would lose our atmosphere incredibly fast. It would be gone. Scoured off means basically blasted away. And we would have no ability to breathe and no atmosphere for any other organism. So kind of amazingly, the magnetic field of our planet creates a force field that protects us. So when the charged particles from the sun hit the atmosphere, they get pushed by the magnetic field toward the poles. They actually spiral inward. So these charged particles come in with a huge amount of energy, and they excite the electrons inside the atoms that are naturally in the atmosphere, right? The charged particles hit the poles pretty aggressively, and the electrons in atoms like oxygen and nitrogen especially get excited, and it causes the famous northern lights and southern lights, or the aurora. And you're going to watch a little more to do with this. So go back to the assignment now and find the links that have been provided to these two TED Talks. They're called TED Ed Talks, kind of formulated as a lesson. And you will be taking a quiz online on the northern lights being actually the result of a fairly dangerous phenomenon that luckily our magnetic field shields us from. The last thing in this slide I wanted to show you is an artist rendering of kind of how this looks. Kind of amazing that some artist has rendered this. Makes the planet Earth look like it's a kind of a spider's body, but that's really just the distortion of the magnetic field, or the Van Allen belts, by the coronal mass ejections or by the solar winds.